Hey guys, it's Miss Kruger from Brabham Middle School. I'm going to help you with a mastery test question. Joshua is 11 years old. So let's go ahead and get started on that question if you need some help on it. So let's see, here we are. So the two strategies that you may be familiar with by now are using a multiplication chart. And if you watched my last video, then I'm a big fan of my favorite, I call them my prime suspects, 2, 3, 5, 7, 11. These numbers always help me in one form or another. So they're my go-to numbers. So you're at this Joshua is 11 years old question, and there's 4 problems there, and it's a lot. So I'm going to help you with these middle 2 right here. And I'm going to give you tips on this one. And I'm confident that you can do Joshua's 11 years old on your own. But I'm definitely going to help you with Gemma and the 2 middle questions because I think they can be a little tricky. So Gemma has 24 balls. Out of the 24 balls, 12 are yellow, 4 are pink, and the rest are red. What is the ratio of the number of red balls to the number of balls that are either yellow or pink? So let's kind of list it out a little bit. I like lists. Lists help me. So 12 are yellow, 4 are pink, and the rest are red. So I need to know how many are red. I know there's 24, and right here I already know that 16 are yellow or pink out of 24. So I need to go ahead and subtract these. 24 minus 16 is 8. So that means 8 are red. Now that I know how many I have red, I can get back to the question. It says, what is the ratio, use a highlighter, use good strategies. What is the ratio of red to yellow or pink? So red, just red, which is 8. 8 to yellow or pink. Now when they say yellow or pink, that means we are combining yellow and pink because it's saying yellow or. So 12 plus 4 is 16. So 8/16. But Ms. Kruger, that's not an option up there. Of course it's not because we need to reduce it. So I'm going to use my favorite prime numbers, 2, 3, 5, 7, 11. Also, I mean, I don't want to jump the gun, but 8 is half of 16. If you are seeing that, then use your number sense to go ahead and select your answer choice. But if you're not making that connection, that's okay. You can use the strategies that we're going to show you to get to that point. So 8 and 16, I focused on my smallest number. Which one of my favorite prime suspects can I use to reduce 8? 11, no. 7, no. 5, no. 3, no. 2, yes. So 8 divided by 2. 2 goes into 8 4 times. 2 goes into 16 8 times. Okay, so I have an equivalent ratio, but it is still not fully reduced. Looking at my 4, I always pick one number. I tend to go with the smallest one. Which one of these prime suspects can I use to reduce this 4? 2, 3, 5, 7, 11, 2. So 2 goes into 4, or 4 divided by 2 is 2, and 8 divided by 2 is 4. Again, I still don't think I'm fully reduced because I still have a composite number here, which is 4. So I'm going to use, again, 2, my favorite prime suspect. 2 divided by 2 is 1, and 4 divided by 2 is 2. And there I have it. I'm all the way down to 1 to 2, and that is right there. So red to yellow or pink is 1 to 2, and you're going to want to take that tile and drag it over here, okay? And that one's gone. Now let's go to a box of chocolates. Get a little separating line, separate your work. make sure you still are using paper and pencil to do this, guys. Or there's plenty of whiteboard apps that you can use on the computer as well. So let's make sure that we're still working these out at home. A box of chocolates contains 84, I got ahead of myself. A box contains 84 chocolates, of which 63 are dark chocolates. The rest are milk chocolates. What is the ratio of milk chocolates to the total number of chocolates in the box? Well, Miss Kruger, milk chocolates, where am I going to get milk chocolates from? They only told me how many dark chocolates. Well, if you know there's 84 in the box and 63 are dark, then that means those that remain are milk chocolate. So we're going to go ahead and do a little work. 84 is our total. Subtract the 63 that are dark. That's going to give us how many are milk chocolate. So 21 are milk chocolate out of 84 total chocolate. Now, you're probably thinking, whoa, that's a big number. How am I supposed to reduce that? Well, that's where I really like the multiplication chart strategy for this, because we can go find 21 and 84 in the same line and see if we can get a reduced fraction a little bit faster. So I'm going to use the multiplication chart for this one. So 21 and 84, let's go on over to our, I'm going to start with that 21. I'm going to look for 21 first. In number 1, no. 2, no. 3, yes. 21, but there's no 84, but 21, nope. 21, no. I'm in line 6, 21, nope. 7, 21, oh, there's a 21, and an 84, yes. So now I'm going to see, because they're in the same line, that means that they can be reduced. To 21 can be reduced all the way down to 3, and 84 can be reduced all the way down to 12. So 21 can be reduced to 3 and 84 to 12. But 3 over 12, we want to make sure we're going to use our prime suspects to check if it is fully reduced, because I don't think it is. So I look at my smallest number. What is the only prime suspect that I can use to divide into this 3 right here? 5, 7, 11 are too big, and 2 does not go into 3. So the only prime suspect I can use right now is 3. 3 divided by 3 is 1, and 12 divided by 3 is 4. So my final 2184 is reduced all the way down to 1/4. So 1:4 ratio. So this last one, I said I'd give you some tips. There are 12 boys and 8 girls in a class. If 2 more girls join the class, what is the new ratio of boys to girls? So again, it has to stay in order, boys first, girls second. So boys would stay the same, 12 boys, but they're telling you 2 more girls joined the class. So we can't say this is 12 to 8, this is 12 to 10. And once we know it's 12 to 10, then we can reduce it to its smallest equivalent ratio. And you might, again, use your multiplication chart, use your prime number suspects. If at any time you think you have made a mistake, you can always check yourself with cross simplifying. So I'm going to just show you what I mean again. 8/16 is equal to, we said 1/2. So when I mean check yourself with cross multiplication, 16 times 1 is 16, 8 times 2 is 16. So I know these are equivalent ratios. The same goes for 21 over 84 and 1/4. Let me kind of some more space here. If I want to make sure, I feel like Ms. Kruger, these are such big numbers. How do I know if I did it right? What if I made a mistake? Well, this is how you check yourself. We're saying that this one and this one are equivalent ratios. So that means when I cross multiply, they should give me the same number. 84 times 1 is 84, and 21 times 4 is also 84. So I didn't make a mistake. I know I did this right, and I was able to check my work to prove that I did do this right. So that concludes that problem. I know you can do that, Joshua, that first portion on your own, and you can finish that last portion. If you still need help, reach out to your math teachers. We would love to help you. Bye, guys.